Rotary dial is the main method of selecting the measurement function. The legend identifies the function of the selection by using common symbols. The white symbol represents the primary function of that selection, while the yellow symbol identifies the secondary function. To access this secondary function of a specific dial selection, simply press the yellow button. Most digital multimeters will offer a variety of test lead connection ports. The white symbol above the test port will correlate to the dial selection legend. In the case of the FLUKE 87, the black test lead will always remain connected to the black port labeled COM, and the red lead will move to the port designated by this white symbol. If the meter is configured for current measurement, and the selection dial is set to anything besides current mode, an audible tone will warn, in addition to the word lead flashing on the display. For most of the measurement modes, an analog bar graph on the bottom of the screen will represent the measured value relative to the range setting. This bar graph will update 10 times faster than the digital display. When the digital display is rapidly flickering between values, this analog bar can be used to gather a better understanding. When using the meter, anytime the lightning bolt is visible on the left side of the screen, there is a differential of voltage potential greater than 30 volts between the two test points. It is possible to have a dangerous amount of voltage present on a circuit, but because of improper configuration, the meter may not display the correct voltage value. This symbol helps to provide awareness when this condition occurs. Now that the basics of the meter have been explained, we will take a quick look at the options available at each dial selection. The first dial position is the AC voltage measurement, identified by a V with an AC sine wave. The leads must be configured with the black lead in the COM and the red lead in the port identified with a V directly to the right of the COM port. Most meters will default to an auto range mode, in which the resolution is automatically selected based on the measurement value. The mode is indicated below the measured value. Pressing the range button will manually adjust the measurement range of the meter. If you do this and wish to return to auto range, you must turn the meter off and return it to the AC volts measurement. Make sure you pay attention to the unit of measure listed to the right of the value. At a quick glance, a circuit that is dead can appear to have voltage, but in fact, the value displayed is in millivolts. If you press the yellow secondary function of the meter while at the AC voltage selection, you will apply a low-pass filter to the measurement. This will disregard higher frequencies. It may be necessary to use this in noisy voltage sources. A common measurement that requires this filtering is a variable frequency drive or inverter output. There are two important things to remember when using this feature. The first thing is never use a low-pass measurement to determine the absence of voltage for safety purposes. A higher voltage than indicated may be present, but at a higher frequency. The second thing to remember is the meter will switch to manual range mode and will require that you select the proper voltage range. The next selection on the dial is DC voltage measurement. The lead connection for this setting is identical to the AC voltage measurement. Just like the AC voltage, most meters will default to an auto range mode, with the option to select a manual range. In this mode, the unit of measure will be in volts only and will not have a millivolt unit, which is instead provided at a separate dial selection. The DC millivolt dial selection provides DC voltage measurement at a fixed range on the millivolt scale. The maximum value measured at this setting is 600 millivolts. A FLUKE 87 has the option for taking thermocouple measurements at this dial selection as a secondary function. If the yellow button is pressed, it simply converts the millivolt value to a temperature using the Type K thermocouple response chart. Most meters come furnished with a Type K thermocouple with test plug connectors. The thermocouple can be joined together to take temperature measurements, or the leads can be separated and connected to a Type K element for field verification. Use the range button to toggle the display between Celsius and Fahrenheit. The next dial selection is the resistance measurement mode. The lead connection will remain the same as the previous 3 positions of the dial. When this option is selected, a small amount of current is passed through the circuit to calculate resistance. This value defaults to auto range mode and allows for a manual range to be selected. The circuit being measured must always be free of voltage for this measurement to be accurate. The unit of measure in this mode can be one of 3 units: ohms, kiloohms, and megohms. While in this mode, a continuity check can be performed. To activate this function, press the button indicated by the tone symbol. While in this mode, measurement with low resistance will produce an audible tone. The measurement range for this mode will be the lowest resistance scale. Pressing the secondary function button at this dial selection will switch the meter to capacitance mode. In this mode, the meter will provide an auto range capacitance measurement with the option for manual range setting. The unit of measure options for this mode are microfarad and nanofarad. Make sure you discharge all residual from the circuit before attempting this measurement. If a charge is left on the circuit, the meter will display DISC, short for discharge. The next dial selection is the diode test function. This function provides a small current which is used for bridging a diode junction. If the silicone gap is bridged, the voltage drop across the 2 leads is measured by the meter. A short beep indicates a good silicone junction, and a long beep will indicate a shorted diode. The remaining dial positions are used for current measurement. All prior measurements covered in this video require the meter to be in parallel with the circuit. For current measurements, the meter must be placed in series with the circuit being measured. For current measurements below 400 milliamps, the probe is placed in the port labeled milliamp microamp. For current measurements over 400 milliamp and under 10 amp, the red lead must be connected to the port labeled amp. The default current type at both of these selections is AC. If the voltage of the circuit is DC, the yellow button must be pressed. In dark areas, a screen backlight can be activated to aid in viewing the display. Pressing the button a second time will make the screen even brighter. A third press will toggle the backlight off. This button can be held in for 1 second to switch the meter to high-resolution mode, which provides a more precise measurement. The min-max button can be selected at any dial selection. Once selected, the meter will begin recording the lowest and highest values recorded. Each time a new minimum or maximum value is recorded, the meter will produce an audible tone. Once you have entered this mode, the screen will show the current measurement, but you can toggle the display to show maximum, minimum, and average values. Pressing the tone button while this mode is active changes the response time of the measurement from 100 milliseconds to 250 microseconds. This will be indicated by a prompt of peak on the display screen. If you wish to stop recording momentarily, press the auto hold button. When you are ready to record again, press the auto hold button again. The range that is used at the point of activation will be locked and will not allow for manual range selection. For this reason, it is important to ensure the range mode is properly set before entering this mode. The auto hold button takes the current measurement and makes it a static value displayed on the screen. This is useful if you are trying to record measurements at specific intervals, buying you time to record the value. The value, however, is not completely static. Once a new stable value is measured, the display will update, producing an audible tone to signal the occurrence. The REL button places the meter in relative mode. When this mode is activated, the value that is present on the leads is used as the new zero condition. All measurements after the activation of this mode will be in reference to the value that was present at the time of activation. This can be used to get a better idea of oscillations to a base value, to compare multiple measurements to one common, or to negate the natural resistance of the meter and test leads. Frequency measurements can be taken during any measurement except for the diode test function. To activate the frequency counter, press the button HZ%. This displays the number of times the signal crosses a specific trigger threshold in a second of time. The trigger point can be adjusted from positive to negative by using the tone button. Pressing the Hertz button a second time will enter a duty cycle measurement mode. This measures the amount of time the signal is above the threshold in one cycle. The auto hold button starts and stops the counter. For every button on the FLUKE, there is a second command that is initiated if it is held in during power-up. The button can be released once the feature is indicated on the screen. In most cases, the meter is placed in a different mode of operation and must be turned off and on again to cancel this mode. Most of these are seldom used, so we will only briefly discuss them. The secondary feature button of both the process meter and the FLUKE 87, if held in during power-up, will prevent the meter from automatically turning off after 30 minutes of no use. This mode will be indicated by POFF on the meter display. While holding the range button down during power-up, the meter will enter a smoothing mode. The smoothing mode will be indicated by an S during startup and will have a symbol visible to the left of the measurement while this mode is active. The analog bar on the bottom of the screen normally represents the current measurement on a 0 to span scale. Holding the REL button during startup will allow the bar graph to represent both negative and positive measurements during relative measurement mode only. The last power-up feature we are going to discuss is the high impedance mode. For high impedance circuits, a simple voltage measurement in parallel can create a disruption to the circuit. Holding down the Hertz button during power-up places the meter in a higher impedance mode during DC millivolt measurements only. It is possible to activate more than one power-up mode by holding down numerous buttons during startup.